whether this means restaurants banning plastic straws, or a transition to clean energy sources, or purchasing carbon offsets, society as a whole has witnessed an uptick in sustainability. And recently, green technology, ya, atau teknologi ramah lingkungan, has become increasingly popular. Green technology refers to any technology intended to reduce the impact of humans on the environment. So, however, despite the rapid development of green technology, it's left some dark side, yeah, from noisy, unsafe machinery, and other severely compromised living conditions. And for so long, having dirtied the earth, the air, the water for more than a century, technology is now showing promise in environmental cleanup. Yeah. So technological innovations specifically aim at reducing pollution from cleaner manufacturing processes to flue gas scrubbers to catalytic converters now figure prominently in mitigating some of the growing pains of an increasingly technological world. So we can see here that technology is like a double-edged sword. Yeah, double-edged sword. We can have some benefits from it, but in the other side, it can also harm the life of the human beings. So this is what we are going to discuss today with three keynote speakers from different academic backgrounds and region. And I hope from this webinar, all of you, all the audience can know, aware, understand, and if possible, make real contribution, even though it's small, to importance of the earth preservation through green technology. So I would like to begin by telling you a short biography of our three speakers here. The first speakers is Professor Qammer Abbasi. So Professor Abbasi is an academic with more than 9 years of research and teaching experience in prestigious institutes, including Queen Mary University of London, University of Engineering and Technology Lahore, Texas A&M University, and University of Glasgow. He taught various courses both at undergraduate, graduate level, and received teaching and research excellence awards. Dr. Abbasi has grant level and has grant portfolio of 7 million pounds sterling and contributed to more than 350 leading international technical journal and peer-reviewed conference papers and 10 books, and received several recognitions for his research, including URSI Young Scientist Awards, University Research Excellence Award from TMUQ in 2 consecutive years, Reward for Excellence from University of Glasgow, UK, Exceptional Talent Endorsement, awarded to early career world-leading innovators and scientists by Royal Academy of Engineering, National Talent Pool Award by Pakistan, International Young Scientist Award by NSFC China, National Interest Waiver by USA, 6 Best Paper Awards, Most Downloaded Paper in IEE Terahertz Transaction, cover of MDPI Journal twice, and Best Representative Image of an Outcome by KEYNOTE. So it's a very wonderful CV that we have here. I think he has joined with us today. Good morning, Professor Qammer Abbasi.
Good morning from UK, and I believe it's afternoon in Indonesia, right?
Yes, this is afternoon, yeah. Professor Qammer. Thank you very much.
Everyone. Good afternoon, everyone.
Good afternoon. Yes, and good morning, Professor Abbasi. Thank you very much for joining us today. And let me go to the second. Oh, wait, I forgot to mention his education background. Yeah, so he graduated from Bachelor in Electronics and Telecommunication from University of Engineering and Technology, Lahore, Pakistan. He earned Masters in Electrical Engineering in 2007 till 2008 from University of Engineering and Technology, Lahore, Pakistan. He earned PhD RF and Electromagnetics from Queen Mary University of London, School of Electronic Engineering and Computer Science, Antennas and Electromagnetics Group, London, UK, and he earned postgraduate certificate in academic practice or PGCAP from University of Glasgow, United Kingdom. And he is now a senior lecturer or associate professor at Electronics and Nanoscale Engineering, School of Engineering, University of Glasgow, United Kingdom. It's a very pleasure to have you. And our second speaker is Associate Professor Dr. Hasliza Rahim. She received the bachelor's degree in electrical engineering from University of Southern California, Los Angeles, USA in 2003, the master's degree in electronics design system from University Science Malaysia, Pulau Pinang, Malaysia in 2006, and the PhD degree in communication engineering from University Malaysia, Perlis, Malaysia in 2015. In 2006, she joined School of Computer and Communication Engineering or SCCE, University Malaysia Perlis or UNIMAP as a lecturer, where she is currently an associate professor with Faculty of Electronic Engineering Technology. She is a chartered engineer, professional technologist, research fellow with the Advanced Communication Engineering Center of Excellence and head of Bioelectromagnetics groups under ACE. She was leading Malaysian Communication and Multimedia Commission Research Grant worth US $200,000. She has been mentoring several undergraduate and about 16 graduate students. She has authored and co-authored more than 160 leading international technical journal and peer-reviewed conference papers, including IEEE Access, Sensors, Microwave and Optical Technology Letter, or MOTL, Progress and Electromagnetics Research, and 3 articles in Nature Publishing Group journals, 2 patents granted, 2 patents fillings, 3 copyrights, and 5 book chapters. And her research interests include conformants, metamaterials, and interaction with on-body communications, antenna and propagation, and wireless body area networks, and also bioelectromagnetics and wearable. Such a very fantastic curriculum vitae. So, Assalamualaikum, good afternoon, Dr. Hasliza Rahim. Yeah, so thank you very much.
Good afternoon.
Good afternoon.
Thank you, Pak Lukman.
Yes, thank you very much.
Sore.
It's okay, it's fine. And also we have a third speaker, that is Dr. Lisa Oksri Nelfia. She is Vice Dean in the Faculty of Civil Engineering and Planning from University of Trisakti, Jakarta, Indonesia, which will join us. Yeah. So just go directly to the presentation session. I will give a chance for the next 30 minutes to Professor Qammer Abbasi to present your material. Time is yours, sir.
Thank you so much for the invitation. Could you please allow me to share the screen, because I cannot share the screen.
Oh yeah, just a minute, sir.
Sure.
Okay, you can now go on.
Let me share it. Yes, I can.
All right.
Okay. Anyhow, yeah. Thank you so much for the invitation and giving such an excellent overview about myself and my research. So before going into detail about my research, I just briefly like to highlight that I am from University of Glasgow. University of Glasgow, if you don't know, it's the 4th oldest university in English-speaking world after Cambridge, Oxford, St. Andrews, and then it's University of Glasgow. And currently, I am the reader, which is equivalent to US professor in James Watt School of Engineering, and deputy head for one of the largest group in Europe working on 5G, 6G and beyond technologies and its application with 110 researchers. And also I am the deputy team lead for University's flagship advanced research center on the topic of quantum and nanotechnology. Last but not the least, I am the pioneering and founding co-investigator for the Scotland 5G Centre, which is a national centre, and in University of Glasgow, we have its urban test bed. So the topic of my talk is moving from contact-based healthcare to contactless healthcare and moving from hospitals to homes. So the idea is that, that nowadays we have so many healthcare devices available, and we have so many wearable devices available, for example, smartwatches, sensors. So the idea of healthcare is changing from doctor-centric concept, where doctor used to guide you about your healthcare, to a patient-centric healthcare, where a person can control their health themselves. So the slide in front of you shows some of the scary facts, and that are projection of health expenditure worldwide. So it is predicted that by 2060, the health expenditure will be significantly higher for both developed and developing countries. For example, for UK, it is expected that health expenditure will be around 12% of their GDP. And this is actually health expenditure per capita. And it is predicted that it will increase by 3 to 4% per person by 2030. And this all is coming from mostly increase in the aging of population. Means that because of good health services, the life expectancy increases, and that ultimately cost health expenditure when we have more elderly population. So the ultimate solution to that is that instead of going to doctor-centric healthcare, where a patient go to hospital, they travel, they are being served by nurses, doctors, and this all includes health expenditures. So if we have a patient-centric healthcare where you have devices which can look at your health parameters at home, and if there is something concerning, then you can go to doctor. So that will save the health expenditure. And this is the vision which I always say that this is how a future proactive predictive diagnosis will look like. We will be going to have in our homes different kind of multi-sensing technologies, including some wearable sensors, some environmental sensors, some RFID systems, and most importantly, nanosensors, where a person will have so many tiny sensors inside around the body, and inside the body they can measure cell temperature, biological changes, and also some non-contact sensors as well, which will be the focus of my talk today. And these all sensors will be working together, collecting information, sending over the secure data transfer system, maybe blockchain or any ledger technology, which will be processed over the cloud by using machine and deep learning. And then that information will be sent to the doctor, who can make some decision and provide clinical intervention and feedback to the carers or either people at home. And there are so many commercial products available in the market. So there are smartwatches. We all have smartwatches. There are geopatch long-term cardiac monitoring sensors and so many sensors available in the market. There are so many implantable commercial products available in the market. For example, insulin pump. One of my favorite is this PillCam. I was recently seeing that it got FDA approval and it can be used now fully in many countries where it can do wireless endoscopy and can take images from inside your body and send it out wirelessly. And then there are some camera-based technologies as well to monitor people. But the issue with all these technologies is either it's wearable, it's implant or vision-based or camera-based systems. They are intrusive. You need to wear them continuously. Implantable technologies is invasive. They have high cost, privacy concern, of course, for camera-based technologies, and some environmental constraint as well. For example, camera need to be in line of sight and so on. So what we propose is that we have these electromagnetic signals around us. So I am by profession bioelectromagnetic engineer and electromagnetic. So our idea is that we have these EM signals around us, mobile signals around us all the time. We have Wi-Fi signals at home. Can we use those signals to monitor someone's health? So basically RF signals are omnipresent and we can use these signals to monitor someone's gait analysis, someone's vital, which are a direct indicator of someone's health. So our vision is to make a non-invasive, proactive, predictive healthcare, which is totally contactless. And how it works is that, for example, Wi-Fi signals have channel state information. There are subcarriers, OFDM subcarriers. Those subcarriers have channel state information. So when they are being reflected from the environment at the receiver side, you do some post-processing, you apply machine and deep learning to detect different kind of activities, vitals, for example, heart rate and breathing rate. And we know that vitals are the first things to be monitored for someone when you go to hospital. So in our group, we are working from many years and we started with monitoring of a single subject activities, either walking, sleeping or laying down. Then we moved to the vitals of a single subject. Nowadays, we are working on monitoring of multiple subject vitals and activities. And more importantly, we are using intelligent reflective surfaces to enhance the resolution of these contactless based sensing solutions. And we are using those for lip reading and gesture recognition as well. So in our lab, what we did some controlled experiments where we asked a single subject to perform different activities like sitting, standing, walking, bending, which are daily life activities. And you can see here, these are the amplitude for channel state information. And you can see that for different activities like walking, standing, sitting, they have different amplitude variations. So we took those channel state information, applied machine learning, and we got an accuracy of classification of different activities of up to 90%. Then we looked at the breathing rate for a single subject in a lab, where we asked the user to perform different breathing activities, for example, normal breathing, shallow breathing, and elevated breathing. And we used our contactless sensing technique to measure the breathing rate. But here the trick is that we compared the result with off-the-shelf sensors. And in this case, we use Go Vernier direct belt. And this blue color is the breathing pattern coming out of the breathing belt. And this orange one is which we measured by using our technique, and our accuracy was 91%, which is very high. So we looked at different activities and disease as well. For example, in case of Parkinson patient, they got freezing of gait. So we mimicked that scenario in the lab where the subject do a voluntarily sudden stop, which is called freezing of gait, and we were able to detect that freezing of gait by applying our technique. And on right hand side, these are different scaleogram for different subcarriers. So one of the issue with people with any injury, for example, in traffic accident or a supporting accident, they are being advised to do certain kind of exercises. And in those exercises, pose is very important. So people do not want to be monitored by camera. So we used our technology, which is contactless based sensing, to monitor and estimate people pose. And you can see that this is people pose, which we have detected by using our technique. And then we used some ground truth data from a KEYNOTE version 2 and also alpha pose software. And the degree of accuracy or correlation was around 92% for pose estimation, which was considerably very, very high. So this video is basically showing a real-time activity monitoring for a single subject. Oops, why it's not working? One second, sorry, it's not working.
Yes, no worry.
Sorry. Okay, yeah, it works. Oh, okay, not work. Anyhow, I can show in this format. So if you can see in this, if you can see in this video, a subject is sitting, and in real time, it shows in the system it's sitting. When the subject stood up, you can see that in the dashboard, it shows the subject is standing. And again, it sits, it shows the sitting status. So this is a real-time activity monitoring system which we have developed to show the different activities of a subject. So this was only for sitting and standing. In our lab, we are currently enhancing it to any other activity as well. So, but the challenge here is, in reality, we do not get a scenario where we have a single subject. We have a scenario where we have multiple subjects. For example, in a care home, even in your home, it's very difficult that it's a single subject living. So what we did was that we tried to estimate number of people in a room and the activities of those people in a room by using 5G frequencies, which is sub 6 gigahertz, and we published in Nature. So what we did that we had 4 different subjects, and we asked those subjects to perform different activities. And this is the lab setup, which was 3 cross 3 meter roughly. Our transmitter was placed at one corner, receiver at other corner. There were 4 subjects with chairs. And we used, as I mentioned, 5G frequencies and an OFDM with 52 subcarriers. And then we performed different kind of activities from these subjects. So this is the real-time setup in the lab where we asked subjects to sit or stand, and we collected around 1,700 data samples for 16 different classes. And we found out that we can detect the presence of a people with their activity. And this was first study in literature about multiple subjects, and the accuracy was around 95%. And you can see that these are the channel state information data samples for different scenarios. For example, this was when the room was empty, when one subject was sitting, when two subjects were present in the room, one walking and one sitting, three subjects, and these were four subjects standing. So you can see that in all cases, the fingerprints were totally different. And by applying machine learning, and in this case, we basically applied deep learning, 1D CNN, to estimate the presence. Now, this was very interesting problem where the idea was to detect the breathing and heart rate for multiple subjects. So the idea is that whenever we go to hospital, what happens is that there are multiple people waiting in a sitting room. And the first thing doctor observes are our vitals. But the idea is that if while we are waiting in the waiting room, we have a system which continuously monitor vitals for all the waiting patients contactlessly. And if there is some kind of abnormality, then doctor can call that patient early, which can save lives actually. So what we did that we measured the breathing rate for 3 and 4 people and heart rate for 3 and 4 people as well in the lab in real time. So what we did was that we used same technique, 5G frequencies, and then we used vernier go direct belt as a baseline. And you can see that this red one is the results coming from our technique, and this black one was the go vernier direct belt, and there was a very close correlation. This is for 2 subjects, this is for 3 subjects. And then we looked at the heart rate as well, and in this case we were using a polar sensor, a polar heart rate sensor, and you can see that this is the estimated heart rate and this is the ground truth from the sensor. The black one is ground truth from the sensor, red one is what we predicted. And the results were very close, as you can see here that it was a very small variation, 85 and 86 BPM. And now we have an opportunity where we are working with the jail people where they want to monitor the heart rate of people from outside the jail. Now there is a demo. So this is a real-time demo for measuring heart rate for multiple subjects. I'll play it here. Let's see. Yeah. School of Engineering and Deeply Network Communication Sensing and Imaging Group. Today we will show you a real-time video demonstration for multi-subject vital monitoring. This includes breathing rate and heart rate by using a contactless solution which we have developed in our group. We are using the polar belt as a reference for heart rate monitoring, and we are using vernier respiration belt as a reference for breathing rate measurement. What we are trying to do here is that we are using ambient radio frequency signals around us to measure the vital contactlessly. So on my left hand side, we have a transmitter antenna, and on my right hand side, we have receiver antennas connected to a software-defined radio. And in the middle of this transmitter and receiver, we have 3 subjects wearing the reference belts. And these are our PhD students. And we are receiving the signal at receiver side. And then we do post-processing to extract heart rate and breathing rate out of it. As we will turn on the system, rate and reading rate. On the left-hand side of the screen, you can see that in the left, we have the reference heart rate coming from molar sensor, and in red is the results which are coming from our contactless solution. On the right-hand side of the screen, you can see we have a reading rate in real time by using the reference and also the contactless solution. And these readings are updated every 10 seconds, as you can see on the screen. So this solution is available to multiple subjects, and next to these subjects are done which we have already completed. So this work is still in progress, and we are basically pending IP for this and still going on. Come on. So another interesting thing we are doing with these ambient RF signal is that how we can use these signals to do lip reading. So one of the project we are working on is to make a fully autonomous hearing aid device which can learn from the surrounding environment and can provide good quality of service to the user without any cocktail effect. And as you know, that camera-based technology is not privacy preserved. So our idea is that we can use these signals to do the lip reading and then feed that into the hearing aid device. And also we will see the surrounding environment and also feed that into hearing aid device so that noise levels can be adjusted in the hearing aid device. And this is the measurement setup for this system where we have a transmitter and receiver focused at the user, and then we are applying same techniques. We are using radar here as well. And interesting thing is that we have basically up to now studied different vowels in a lab environment by using 5G frequency and radar, and our accuracy was above 80%. And another interesting thing we have observed recently is that with the using these radio frequency signals, because of COVID, you know, everyone is wearing masks. So it's so difficult to see even by using camera technology what someone is saying. But with our radio frequency technology, we can get an accuracy of up to 80% for the people with mask as well, which is a very revolutionary thing, that how we can use our technology in COVID as well, where people are wearing masks. And this is work in progress. We are working on it. Currently, we are only up to vowels, but we are moving forward. Then one of the challenge here is that with all the work I presented, in order to get high resolution and high accuracy, we need more data. And the challenge is that the environment, it's so difficult to control the signals, the radio frequency signal. But one of the revolutionary technology which is coming soon and it's very hot is basically using intelligent reflective surfaces. We call it wireless on the walls. That what we do, that instead of making any changes to transmitter or receiver side, which we do in mobile technology, we are now making changes to the channel side, where we will put these meta surfaces. These are called intelligent reflective surfaces, passive in nature. We can put them on a wall, either in a wallpaper, in a window, and we can use these to control the radio frequency signal direction, to control the beam, to control the phase, and we can use that to track people as well where they are going. So beam can follow them, and also when we will focus beam on someone, we will get more data, and that will ultimately help us to get high resolution. And we can do some even more crazy ideas about gesture recognition for people, with this language, gesture language. And in University of Glasgow, we have developed the intelligent reflective surfaces test bed. And this is one tile. So we have made a tile-based structure. So this is one tile which has 64 unit cells, you can see. And we have made it at sub 6 gigahertz at 5G frequencies. And our total test bed has 16 of these tiles, which has around 4,096 elements. And you can see this is our complete test bed, which has 4,096 elements. And this is, you can see the wave phase, which it's showing. It's showing the wave here, and I'll show you the video demonstration as well. And this is the back side of this IRS, where we have pin diodes to control this structure, and each element is taking a current of 2 milliamps per element, which is very less. Then the previous 1-bit hardware can give you a phase shift of 0 degree or 180 degrees. So you cannot control the beam so much. So we move to 3-bit intelligent reflective surfaces, where you can have a phase shift of up to 45 degree control. So you can have 8 different states where I can focus or change my beam direction to either 0 degree, 45, 90, and so on. And this IRS has again tile-based structure. These are 6 tiles, and each tile is basically having certain number of elements. So the total elements we have in these 6 tiles is 2,304 unit cells, which are used to control the beam. So we did some of the testing. So what we did is that we put our transmitter antenna here, receiver here in 2 different rooms. They were totally non-line of sight. And here is our intelligent reflective surface. And then we try to see that how much improvement we get from this structure in terms of signal strength, and also how it can be useful for activity monitoring. So there is a video demonstration. I think it will not work this way. Have been developed in University of Glasgow. It has more than 2,000 unit cells, and it is working in sub 6 gigahertz. Video is not being streamed. So as soon as we have configured our IRS, you can see that signal strength is going up, and then video streaming will stop. And our signal quality is increased by 25 dB by using So because I have only 2 minutes left, so one of the interesting experiment we did was basically for activity monitoring with and without IRS. So this was the activity area. So we turned the IRS off, transmitter and receiver were in different room. We did some activities, and then we turned on, and the accuracy of detection was around 53%. Then we turned on our IRS, and the accuracy was improved by 47%. So this was very initial results which we did, but now we have a large campaign of measurements ongoing for IRS enabled activity monitoring. So I think I'm exactly on time. The idea is that the main takeaways are contactless sensing has a potential to support independent assisted living. We have been working on vitals and activity for single subject, but we are taking it further to multiple subject, and most importantly, we are trying to do tracking as well. So this is First Minister of Scotland. Our group is involved in various activities. Many books I have published with other colleagues, and we are organizing some conferences as well. So one last thing, but not the least, this all work is done by my colleagues, my students, postdocs, and collaborators. And indeed, success is a group achievement. So thank you so much. I'm open to any question. I think I'm exactly on 30 minutes.
Okay. Thank you very much, Professor Abbasi, for your wonderful presentation. If I may take some summary from your presentation, there is a change, from doctor-centric to patient-centric, in which people now can check their health condition by themselves. This is also, if I may reflect, my family is also doing this, although with a very simple blood pressure device, something like that, or heart rate device. So, but what you have presented is far more beyond than what we are doing here. You trying to develop some wearable device, motion sensing, tiny sensing, non-contact sensing, in which all of these devices can collect information from the patient, and also it will be sent and analyzed to a group of doctors, and the doctors can then decide some clinical intervention for the patient. I think it's a very amazing research that you have done there, Professor Abbasi. So we will please, if you may, you can please stay with us, because we will have a question and answer session later. But for now, let's go to the second presenter, that is Associate Professor Dr. Hasliza Rahim.
So someone asked about the YouTube link, so I'll share the demo YouTube links here in the window. I will do it.
Okay. If you have it, you can share it, Professor Abbasi. Yes, thank you. And meanwhile, Professor Dr. Hasliza, are you there? Dr. Hasliza?
Yes, I'm here.
Oh yeah, thank you very much. So you can start your presentation, Dr. Hasliza, for the next 30 minutes.
I will share the slide. Okay. Okay, so thank you very much, Mr. Lukman, and also as the conference chair, for giving me an opportunity to share my knowledge and also experience in this conference that focus on the green technology. Okay, so the title that I will cover today is more to my expertise area, which is wearable antenna. And I will share the knowledge and also overview for, with the 5G and beyond technology issues and challenges that clouds when we design the wearable antenna. So I'm Hasliza. Okay, so before we go deep into 5G technology, so I would like to introduce some of the key terms that always being used in 5G. So people are talking about 5Gs here and there, but then we don't know the key terms that or the key points of the 5G. So these are some of the important keywords for the 5G. MM wave. So we have to know what is MM wave. It is high frequency between 17 to 100 gigahertz. It's very high frequency, which is beyond than 2G, 3G, and also 4G, and it has high bandwidth. And because of this high frequency, it has a very short frequency range. Okay. And for millimeter wave, they focus on this deployment in a dense populated area. For the sub-6 gigahertz, this is more like a Wi-Fi frequency between 3 to 6 gigahertz. This is where the area that we are working for in our research. For the small cell hub for indoor use or outdoor base station for medium range. And another one is the low band, which is below than 800 megahertz. In Malaysia, the low band 5G networks is 700 megahertz. This is used for the very long distances. And it provides blanket backbone coverage. And of course, in 5G base station, we implement the beamforming used in sub-6 gigahertz or millimeter wave base stations to direct waveform towards consumer devices. So it means that it's very focused to save the energy actually. So, and also to maximize the data transmission and to reduce the losses. So it can cover range and direction limitation of high frequency waveforms. And of course, for the 5G, there is another technology which is going to be implemented in 5G is massive MIMO. So MIMO here stands for the multiple input, multiple output. So this is a system that uses antenna arrays with a few hundred antennas simultaneously serving many tens of terminals in the same time, and also frequency resources. So massive word here refers to high number of antennas, which is minimum 50 antenna arrays. Okay, so let's take a look at the evolution of the technology. As shown in this figure, mobile communication technology has been evolving into a new generation every 10 years. So from 1G, 2G, 3G, so every 10 years. While mobile communication services have undergone a major change every 20 years. So if this trend continues, a third wave 5G is anticipated to be bigger than the previous one, fueled by the technologies of an upgraded version of 5G. This is what we call as a 5G evolution, and the following 6th generation 6G, and to support industry and society in the next 10 years. Okay, so what is 5G? So 5G is characterized by high data rate or high capacity, low latency, very minimum delay, and massive connectivity. Okay, so as we can see in this slide, Indonesia will roll out the 5G networks in the early next year, similarly with Malaysia in 2022. So we are in the same phase. Okay, so with this feature, 5G is expected to further upgrade multimedia communication services from the level achieved by the previous generation, including 4G. And yes, we are moving towards more and more advanced technology and to provide new values as a fundamental technology that supports future industry and society, along with artificial intelligence and also Internet of Things. Okay, and now we move to the 6G. Okay, so 6G stands for the 6th generation, and vision of the 6G networks is illustrated in this figure. So first of all, 6G wireless communication networks will be space, air, ground, sea integrated networks. So it will cover all surrounding, all environments, our space, our air, ground, and also sea, and this will be integrated into one network to provide a complete global coverage. The satellite communication, okay, so here is the satellite. UAV communication, maritime communication will largely extend the coverage range of wireless communication networks. Why? Because these large integrated networks will provide a higher data rate compared to the 5G, all spectra will be fully utilized, including sub-6 gigahertz, millimeter wave, terahertz, and also optical frequency bands. And to enable full application, artificial intelligence and machine learning technologies will be efficiently combined with 6G wireless communication networks to have a better network management and automation. So 6G is more towards the intelligent wireless communication networks. Furthermore, artificial intelligent networks can enable the dynamic orchestration of networking, caching, and computing resources to improve the performance of next generation networks. The last but not the least strength is the strong network security for both physical layer and network layer when developing the 6G networks. Industry verticals such as cloud, virtual reality, Internet of Things, industry automation, cellular vehicle to everything, digital twin body area networks, and energy efficient wireless network control and federated learning system will largely boost the developments of 6G wireless communication networks. Okay, so we would like to know what is the requirements of this 5G and beyond technology that specifically focus on the 6G. So in the 6G networks communication, we will have extreme high data rate, which is more than 100 gigabits per second, more than 100 times capacity for next decade, extreme high uplink capacity, and for the coverage, it will be extremely coverage that cover sky, sea, space, and etc. And the data rate will be in gigabits per second coverage everywhere. So we are talking about a very high data rate for the 6G network here. And also in terms of energy, it will be extremely low energy and cost. So here, the 6G will implement the green technology that will be harvested from the solar, from the ambient radio frequency and so on. And the device also will be free from battery charging. Okay, so in the 6G, it will implement the wireless power transfer. And in terms of low latency, it will have a extreme low latency, which is less than 1 millisecond. And people will not have to wait when they want to watch the YouTube or they want to watch the TikTok and so on. So it will be very fast in this future network communication. Okay, so in terms of reliability, the percentage of the reliability will be close to 100%, which is 99.999% reliable, and also it will be secure, private, safe, and resilient. Okay, so in terms of massive connectivity and also sensing, it will support massive connected devices, which is up to 10 million per kilometer square, and very high positioning, which is less than 1 centimeter. So the requirements for the 6G is very impressive compared to the 5G. However, now we are trying to deploy. Okay, so the country in all over the places are in the phase of deploying the 5G, but in the next future, perhaps in the next 5 years, the 6G will take place. Okay, so choosing the right antenna for an application, especially for the wireless body area networks, the contactless sensing application that has been highlighted and also delivered by Prof. Qammer Abbasi just now, is a key design challenge. So I will briefly review 4 recent antenna design for 5G and beyond. for the application such as the ambient RF energy harvesting and so on. Okay, so in the first paper, the article by Ju et al., a compact coplanar waveguide CPW5 liquid crystal polymer LCP based tri-band antenna is presented. So as we can see in this figure, fabricated for the WLAN, WiMAX, and 5G systems. So this antenna is covered for the sub-6 GHz 5G system, and it is printed on a 0.1 millimeter thick LPC substrate, combines two strip. So this is a strip with the main radiation rectangular patch and CPW ground, and has a small overall dimension of about 20 millimeter by 32 millimeter by 0.1 millimeter thickness. The operating bandwidth, it has 3 for the WLAN, WiMAX, and also 5G with a reasonably good gains and good radiation characteristic in all operating bands. The performance of the antenna remain reliable under bending conditions. So this antenna is can be used for the on-body wearable application, especially to harvest the ambient radio frequency from the air. Okay, so next is the second antenna is the recent 5G millimeter wave wearable antenna by Q et al., which is compact, flexible, transparent. It is see-through, as we can see in this figure. MIMO, multiple input, multiple output antennas based on embedded metallic mesh, as we can see in the figure. The phase array properties of the fabricated prototypes with 0 degrees scanning angles are emulated using the ratio 8:1 in phase power divided feeding networks, which consists of a standard corporate design with Bellevue T junction and the tapered transformers. The design of 5G MIMO antenna based on the EMM as a base isolation above 20 dB, which is good. Envelope correlation coefficient ECC under 0.005 and operation in 5G N79 band ranging from 4.4 up to 5 gigahertz. So this is the performance for the sub-6 5G, and a maximum gain of 9.6 dBi is demonstrated in the 26 and 28 gigahertz band. Okay, so this graph is for the millimeter wave frequency, which has a very good gain. Okay, another recent 5G millimeter wave wearable antenna by Jilani et al., millimeter wave liquid crystal polymer based conformal antenna array. Operating frequency is Ka band from 26.5 to 40 gigahertz, and the antenna is small and also compact, that has the size of 11 by 12 millimeter square. The design is extended into 2-element array for the gain enhancement, and the proposed antenna array .35 dpi at 35 gigahertz. And consistent high gain profile of above 6 dBi in the complete Ka band. So which is have excellent performance in terms of gain and also bandwidth. Next is the recent 5G millimeter wave wearable antenna by Wage et al. Presents a broadband millimeter wave rectangle. The first rectangle realized on a flexible textile substrate for wearable application, which is specifically for the RF energy harvesting system. So we can use this kind of antenna and position it on the human body for the energy harvesting. The patch dimension are also small, which is 9 by 7.125 millimeter square with a 3.25 millimeter inset microstrip feed. Okay. Right, as we can see in the right figure, the proposed novel antenna bandwidth extends from 23 to 40 gigahertz, which is achieving the ultra wideband, minimum radiation frequency of 67% up to 30 gigahertz, over 3 dB improvement compared with the standard patch. A stable gain of more than 8 dB is achieved based on a textile reflector plane. So this is also excellent performance of the wearable antenna used for the RF energy harvesting that categorized under green technology. Okay, so what are the main issues and also current challenges on the 5G millimeter wave wearable antenna? So of course, the first challenge will be how to make it small size for this antenna. The second is a lower gain. So how we want to increase the gain. The millimeter wave band requires a high gain with a broadside radiation pattern. Why? Because we want to combat high power losses in electromagnetic wave propagation. So that's why we need to design the wearable antenna which has a high gain. And this is the main challenge when we design the 5G millimeter wave wearable antenna. So most state-of-the-art 5G millimeter wave wearable antennas are presented either a single element or single port. Okay. However, for the 5G millimeter wave, MIMO technology must be implemented, and MIMO technology is considered significant in realizing high-speed data transmission via 5G millimeter wave bands. So we are still lacking on the MIMO antenna designs. And the fourth one, the most common problems with the wearable antenna is the bending condition. So we have to ensure that the 5G millimeter wave wearable antenna should be robust against this bending condition, because we want to place this kind of antenna onto the human body. Okay, so the future direction of 5G millimeter wave wearable antenna, we start with the rigid antennas. Now we're moving towards 5G millimeter wave wearable antenna, which is still not many researchers around the world are designing this type of antenna. And now we are looking at the more challenges compared to the 5G millimeter wave wearable antennas. Okay, so I also published one recent paper in IEEE on the MIMO wearable textile antennas for the sub-6 gigahertz, and the design can be extended for the 5G millimeter wave wearable antennas. So with that, thank you very much for giving me opportunity. Yeah, you can ask me any question regarding this kind of topics. Okay, so thank you.
Thank you very much, Professor Hasliza Rahim, for your wonderful presentation. And you have talked a lot about the development of technology in terms of the change, from the 1G, 2G, 3G, 4G, 5G until 6G. And you know that I just changed my phone card, from 3G to 4G yesterday. So if you talk about 5G and even 6G, that will be a very slow development in my side. But I'm amazed with what you have done, what you have written in your research and your publication. It's quite amazing, and hopefully Indonesia as well as other countries in Southeast Asia can enjoy the new technology by 2020, 2030, Yeah, and yeah, that's it. So thank you very much, Dr. Hasliza. And now please stay with us because we will have a question and answer session. And for the audience, you can write your question directly in the chat feature, or you can press the raise hand button, yeah, so that I can call you in order of your raising hand to deliver your question directly to our speakers today. And now we will move to the third speaker, which is who is Dr. Lisa Oksria Nelfia, but apparently she couldn't come live, yeah, with us today. But luckily, she has prepared a presentation that will be played by my team. So have a look at her presentation.
Good morning, ladies and gentlemen. It's a great honor and a pleasure to meet you all here, albeit virtually, on this blessed occasion of the first LITE International Seminar Lekantara. First of all, thank you for allowing me the time and the opportunity to be here as a keynote speaker for this event. Thank you to Mr. Aulia Lukman Aziz, MPD, as a moderator, and also as a CEO Lekantara. I would like to quickly introduce myself. My name is Dr. Lisa, and I have been an assistant professor at the Faculty of Civil Engineering and Planning at the Universitas Trisakti, Indonesia. I graduated PhD in France at the La Rochelle University, where I started researches about recycled concrete as a cement substitute. Indeed, cement is the source of about 8% of the world's carbon dioxide emission, according to think tank Chatham House. Nowadays, and in every field of research, it's vital for everybody to join effort against what could limit the actual climate change. But coming back to my country, I have been aware that mining activities as nickel, iron, coal were the third source of the environmental pollution. The slag was the cause of pollution, harmful and toxic substance, and I'm talking about incredibly high amount. I decided to adapt my research with a new concern and a new material. And today, I'd like to share with you how using high magnesium nickel slag crushed into powder as a replacement for a cement is one of hopeful topics today about the present green technology field. My presentation this morning is divided into 4 main sections. First, I will introduce the green concrete topic, then I'll present one study I lead with my student and my colleagues, explaining which materials and method I used. Then I will expose the results of this method. Finally, conclusion and perspective will be exposed. So the big question is, why using green concrete? Concrete which is made from concrete waste that are eco-friendly, as one of its components, it's called green concrete. This is concrete uses less energy in its production and produces less carbon dioxide than conventional concrete. We tend to produce green concrete for many reasons. First is to reduce the CO2 emission. Second is to decrease the demand of conventional materials. And third is to recycle and reuse the material waste. But also how to reduce the environmental impact associated with the cement manufacturing by infrastructure development. The need for construction and buildings material is more or less 30 million tons per year, cement only, excluding coarse aggregate and fine aggregates. The purpose of this type of concrete is to reduce environmental problems, such as global warming, the over-exploitations of natural resources, and the waste obtained from the quarry, household, or construction sites. The use of cement in a building construction or for other infrastructure work creates negative impacts on the environment. In some research, the cement was partially replaced by pozzolanic waste as fly ash, which is come from coal burning electricity generation, and granulated blast furnace slag or GGBFS from iron production waste also use our gypsum or limestone filler. Such as method will reduce the carbon dioxide emission that come from its clinker production. According to the recent research about green constructions, eco-friendly, the cement quantity can be modified by using pozzolan substance such as fly ash, nickel slag, GGBFS, and recycled crushed concrete fines, and other alternative materials can be used like oyster shell, spending bleaching earth. For the example, the incorporation of recycled concrete aggregate or RCA in a concrete is a possible solution alternative to their use as a gravels in a road application. However, RCA can have a negative effects on the concrete properties. RCA tend to alter the workability because they absorb more water than the natural aggregates. Compressive strength of a concrete with RCA can be up to 40% lower, depending on the substitution level and the quality of the origin of aggregates. Most of indicators of durability are affected by the presence of recycled coarse aggregates. On the other hand, the spending bleaching earth is a solid waste material generated as a part of the refining process in the edible oil industry. Spent bleaching earth is usually disposed of in landfills or waste dumps. Due to increasing cost of disposal and being an environmental hazard, it is desirable to recover oil using a solvent extraction process in an efficient and economic manner. Before disposing of spent bleaching earth as per environmental regulations, it's used to produce the eco-friendly concrete by utilizing the industrial production residue. The substitution of cement is effective for reducing the carbon dioxide emission during production, especially when it's combined with an additional substance. So what kind of green concrete application for the future do we have already studied? First of all is the geopolymer concrete based on GGBFS and nickel slag powder. Geopolymer concrete is a combination of fine powdery materials and liquid component of mix made of alkaline chemicals. One of the materials that can replace OPC is fly ash, but other materials can be used as a mineral additions such as silica fume, GGBFS, rice husk ash, and metakaolin. At the present, fly ash appears to be the most promising source materials for large-scale industrial production of GP, but depending on the materials for the binders, actually GP can have a wide variation of characterization. Based on literature, nickel slag provides the potential for geopolymer production due to its high silica content. Nickel slag is usually used for landfilling, utilizing industrial waste as a geopolymer concrete can also reduce CO2 emission from cement production, which is a sustainable development of the cement and concrete industry. Geopolymer concrete is an innovative concrete using chemical action of inorganic molecules such as a nickel slag and steel slag. Both materials can be found in iron industry as waste. Those can endanger soil and groundwater because of the excessive amount. Nickel slag powder and GGBFS can be alternative for cement substitution because both materials react with alkaline solution as an activator to bind concrete mixture. The observed composition for experiment for this one is 50% NSP, 50% GBFS without any cement with a different molarity. Sample will be cured at 60 degrees with a steamer for 4 hours, and the compressive strength of the geopolymer concrete with 4 molarity and 8 molarity at the 28 days respectively are around 6 and 7 MPa. The process of making the span pile utilizing centrifugal force and the compaction process that can result in even compressive strength in the thickness of the pile. Manufacture of laboratory scale span pile with the geopolymer concrete is an environmentally friendly concrete innovation using 100% industrial solid waste without cement. Is one of the concrete technology applications that can be used in the future. Using nickel slag powder incorporated into the main constituent of hydraulic rod binders for the treatment have found that this valorization way is an alternative to the use of natural and artificial materials. Let's talk about the lightweight concrete. Lightweight concrete is a concrete containing lightweight aggregate and balance density between 1140 and 1840 kilogram per meter cube, according to Indonesian standard. Concrete that uses light aggregate, a mixture of light coarse aggregate and natural sands used as a substitute for light fine aggregate, has provisions that must meet the specific gravity of lower than 1850 kilogram per meter cube. This aggregate substitute mixture can be obtained from the result of the plastic waste, cored clay, expanded, or the result of burning clay, shells, slab, perlite, vermiculite, or slag, and so on. This invention is related to a lightweight concrete composition that is environmentally friendly, more especially an environmentally friendly concrete composition made of cement, like clay expansions, styrofoam waste, and steel GGBFS. Cement is an important ingredient that function as an additive in concrete mixture. The use of cement produces a large amount of the carbon dioxide emission, which is one of the causes of the greenhouse effect. To overcome this, it's necessary to improve the quality of environmentally friendly structural lightweight concrete through the use of the lightweight expanded clay aggregate and additive. In addition to binders that have been developed to reduce the use of cement, such as iron slag and nickel slag and others. According to the Indonesian Ministry of Energy and Mineral Resources and to the Indonesian Iron and Steel Industry Association 2017, Indonesia ranked second in the nickel productions. Nickel natural resources has 4 billion tons and nickel ore production is 40 million tons per year. 30 million tons will be nickel slag. Iron slag reaches 1.4 million tons per year in West Java. And therefore, we should find out a strategy that can be used to treat the waste by using the concept of sustainable engineering as to reduce future environmental problems. With the geopolymer concrete technology above, it's hope that the nickel slag and iron slag can be utilized in the manufacture of a geopolymer concrete and replace cement in the manufacture of a concrete, thereby reducing the impact of cement production itself. And that can make nickel slag and GGBFS as an environmentally friendly alternative materials in the manufacture of a concrete for construction. As I mentioned before, in order to explain the context of the study and the problem induced, I used a 2018 study from the Indonesia Ministry of Energy and Mineral Resources. According to the study, it's estimated for Indonesia at 97.4 billion tons of potential nickel mineral resources in Sulawesi. From nickel ore production, only 40 million tons of nickel ore are smelted, producing 30 million tons of nickel slag. Unfortunately, only a small part of this waste, only 4.6 million tons, are intended to slag processing, and they're used mainly for roadworks. Recently, Indonesian government demanded that 75% of waste should be recovered by 2027. On the other hand, the use of cement in a building construction or other infrastructure works creates a negative impact on the environment. The literature revealed that each ton of cement production generates nearly 0.8 tons of carbon dioxide, which is released into the atmosphere. It's caused from using a large amount of energy and a high temperature of approximately 1450 degrees Celsius to produce the clinker, which is the main component of cement production. Hence, the industrial cement causes 5% of the greenhouse gases emission. What I would like to tell you is that the studies concerning the use of powder from nickel slag as a replacement for cement are very few. Regarding to the objective of our work, there are two aims. In one hand, finding a new ways of valorization for nickel slag, and more particularly creating a new production chain for concrete. On the other hand, studying the properties of fines obtained by crushing and sieving of slag as a mineral addition. I will therefore approach in this presentation the material of the powder from Sulawesi, Indonesia. Then I will expose the method used. Firstly, physical chemical characterization of the fines, and secondly, the characterization of the concrete based on the powder. First part, therefore, materials and working method. The nickel slag used was obtained from Sulawesi, Indonesia. This raw material was prepared by using industrial ball mill coming from PT Growth Java Cilegon near Jakarta, Indonesia. In order to obtain a granular size less than 0.075 millimeter, the nickel slag powder was filtered by sieving it with a machine strainer of 200 mesh in a dry condition. After the sieving and straining process then took 10 minutes, the NSP was produced. Regarding the characterization of the nickel slag powder, we first studied the physical characterization by laser particle size, then by the absolute density, and then finally the specific area powders. We also did the trace metal by atomic emission. Then the chemical composition of NSP was obtained from X-ray fluorescence by using epsilon 5 analyzer from Analytical. Finally, to study the mineralogical characteristic of powder, we used the scan of electron microscope. To use the nickel slag as the supplementary cementitious material, or that we call SCMs, the concrete was designed on the Japanese International Standard GIS 5004 with almost 56% sand in the total aggregate volume of refraction of sand fixed and the cement water content of 0.47. For testing fine aggregate and coarse aggregate based on GIS 5004, the fine aggregate passed the clean liners test. Ordinary Portland cement type 1 used was Tigaroda. And then composition of the concrete mixture was compared with the compressive strength target 30 MPa. The compressive was made by gradually substituting the mass of cement by the nickel slag powder from 0% to 25%. For this experiment, the total sample were 72 specimens. The comparison of water ratio to the cement mixture and NSP is a constant. And the water and the paste volume were constant. Compressive strength was tested at the ages 3, 7, 14, and 28 days. The research analyzed the workability by using the SLAM test with Haber counts. Furthermore, a test was conducted on the workability of a concrete to determine the value of the SLAM from each concrete produced in cylinder form. The compressive strength was analyzed based on the STMC 470 within a period of 3, 7, 14, and 28 days with a digital compression machine pilot press. Before testing it, the concrete should be cured in a water temperature of 20 degrees. In a making concrete sample, it should be underlined that concrete was made without the addition of superplasticizer. Indeed, it's known that the chemical mixing can modify the hydration kinetics. To define the properties of concrete, we measure the mechanical strength of the concrete specimen in compression. At the same time, we follow the scanning electron microscope test, which practically helps to visualize the microstructure of the hydrated cement paste. In addition to aggregates and examining surface texture, the raw surface make measurements of paste abundance and reliable. I move on to the third part of this presentation, which will be some results of the study. The result obtained from the absolute dry density, specific area, and the median diameter are shown here. The absolute dry density of nickel slag powder was 2.75 ton per meter cube, and the cement was 3.15 ton per meter cube. The absolute dry density of NSP was smaller than the density of cement. In addition, the NSP specific area was higher than cement. Therefore, the nickel slag can be a supplementary cementitious material according to the literature. It also influences the compressive strength and the workability result. Figure on the left shows the particle size distribution with median diameter of nickel slag powder at a 15.4 micrometer was almost the same as the median diameter of the OPC type 1 at a 14.90 micrometer in the figure on the right. The particle size, the distribution of the nickel slag powder may have some benefits in the partial replacement of cement in a concrete mixture. According to the trace metal testing for raw material analysis, the results show that the arsenic, cadmium, and mercury level were below the threshold of the nickel slag powder, referring to the literature. Hence, this substance is very safe for the environment and can be implemented as the new substitute of cement. This material has been accepted by cement industry under their criteria for the trace element solid waste. About the mineralogical characterization of powder, scanning electron microscope of the nickel slag is presented in this figure. It contains silica, calcium, magnesia, and alumina, and it shows that the slag particles are sharp and irregular. The result of chemical analysis by X-ray fluorescence technique confirm that the SEM images about the main components of nickel slag powders. After studying the properties of powders, I will now expose to you the chemical and mechanical properties of a concrete containing nickel slag powders. The figure shows that the results obtained from the SEM images and EDS test on the mineral composition for NSP with a substitution rate of 20%. The EDS data result was carried to identify dominant element of NSP. In the figure top left, the SEM image was magnified 500 times. According to the result, the image formed a particle that contained mineral element as iron, calcium, silica, alumina, and magnesia, which is explained in the EDS result in the figure below left. In addition, figure right left shows the same SEM image magnified 2,000 times. This figure shows that the silica and calcium and magnesia, the EDS result, the dark color indicates the presence of silica, and when it's lighter, it's containing iron. The workability test shows that the presence of an NSP in a concrete has a higher result consistency than the conventional concrete, whatever the substitution rate is. According to the recent research, the workability result is in each substitution level is always higher than the material reference. It means that the nickel slag doesn't absorb water, low water absorption. This result is surprising considering the fineness of NSP particles finer than cement. Material tends to affect the rheology of a concrete because it absorbs less water and increases the compactness of the granular skeleton because of their nature and shape. The influence of NSP on the compressive strength is based on the data provided in this figure. This research concludes that the compressive strength for the 20% partial cement substitution is FC prime 30 MPa at the 28 days. Above 25% substitution of cement, the compressive strength is below 30 MPa. And so below the compressive strength is referred. Based on the research, it stated that there was a power increase in each age due to its high density level and low porosity. It is influenced by a higher nickel refinement, the higher the cement substitution by nickel slag is. The lower the compressive strength is obtained with a different curing times. Based on European standard EN 261, the substitution of cement level must not exceed 25% because it will affect the mechanical characteristics and durability of the concrete. We can just draw three conclusions at the current state of our research. Firstly, NSP can be used as a substitution for Portland cement in the concrete mixture, and its expected to become a green alternative construction material. And secondly, in general, the often result reveal that an NSP can replace until 25% of the cement in concrete without altering properties of concrete. And lastly, it can be used as a mineral addition in the composition of a concrete without a substitution rate of a powder equal to 25%. I hope this presentation about green technology in civil engineering field was useful and interesting for this audience, and I would like to thank you for your attention and your time.
Right. So that was the presentation from Dr. Oksri Nelfia from Universitas Trisakti, Jakarta, Indonesia. And she mainly points out the green concrete technology because her background is from civil engineering. And she tries to test out some materials that she believes that it can be a replacement for the conventional material, so that the technology that we can we use for buildings can be more friendly to the environment. Yeah, such as some benefits are to reduce the CO2 emission, to decrease demand for conventional material, and also to recycle and reuse the materials. All right, so that was all the presentation from the three speakers. I'm so happy that now the development of technology can do more benefit rather than harming the environment and also the people in the world. So now I'm happy, I will be happy to take some questions from you. If anybody wants to raise hand to ask directly to our speakers, or do we have any written questions here? Okay, there are questions here from the chat room. Okay, let's have the first question. All right. Okay, so this is from Pak Imam Mahrudi. Yeah? Thank you very much, Pak Imam, for writing question to Professor Abbasi. Yeah, and you state here that, as you know, in some parts of the world, the modern institutional authority structures have been secular rather than religious. All right, this is a very interesting issue. So how do we have to build the framework of the ultimate structures in institutionalizing elements, i.e. in recognizing, introducing healthcare monitoring system that define the sacred of the doctrine on Jews, Christianity, Islam, and others, and related to the profanity claims on amassing the wealth, freedom, and lives. All right, I believe this question is directly to Professor Abbasi, but is he still here? Let me check. Yeah, apparently he has left the room, Pak Imam. So I believe this issue is very related to what Professor Abbasi's presentation. So we have to move to the next question. Is there any second question? Oh, okay. This is another question from Pak Imam Mahrudi, and you say that you borrow part of the lyrics of Kenny Rogers' song, "The Islands in the Stream." Is the iron industry be perspected as the islands in the stream that is away from us in the future? All right. So again, I'm afraid Pak Imam, Dr. Lisa is not coming directly today, but we will save your question and we will deliver the question to Dr. Lisa, and she has promised us to respond to any questions from the audience later. Yeah, so please stay with us, yeah, Pak Imam, later after this meeting, because we will hopefully get back to you with the answer to your question. All right. So do we have any other question? All right. So we have no question. We have no further questions, yeah, from the chat room. But we have Dr. Hasliza here. Yeah, I would like to ask a question. Actually, this is a very simple question from somebody who is not studying engineering or technology right now. And actually, Dr. Hasliza, what are the challenges, yeah, to develop such a technology, especially in developing countries like Indonesia or in Malaysia in your case? What has your country done to prepare for the 2030?
Okay, thank you very much, Mr. Chairman, on the question. Yeah, it's a very good question. So I know that for the developing country like Malaysia and also Indonesia, we have several challenges, especially for the advanced technology like 5G, because it requires skills and also costs. Yes, the cost is very expensive, and we need to import some of the equipments from the outside, especially from the Europe. In Malaysia, for the backbone of the 5G is supplied by the Ericsson. So Ericsson is the one who are the one that responsible for the implementation. So we are using all the equipments and also the devices and also the backbone of the 5G to deploy the 5G in Malaysia. And of course, to deploy the 5G in Malaysia, we need investors. So, so these investors can come from the China or from the Japan. So these are the challenges lah, to get the investors, to get our country ready with the 5G, and also to ensure that the basic backbone of the 5G is ready. Okay, so to deploy the mid-band and also low-band is not as challenged as the millimeter wave. Millimeter wave, you need to deploy a lot of posts, what we call as a picocell. In 100 meter, you have to deploy one post, one pico base station to transmit the 5G. So this costs, this increase the costing of the 5G. So that's about it. I think the main problem that hinder us from moving forwards is costing. Yeah. Like in China, in Europe, they do not have problems. They already deploy the mid-band, the low band for the 5G, because they are advanced country, they have a lot of monies, and they invest for the, they invest for the future so that they will get the return of investment. In terms of business, as we can see now, during the pandemic, we cannot meet each other, right? So we have to communicate through the PC, through our internet. And then, yes, in Malaysia also, we have this poor coverage. Yeah, sometimes you can hear my voice like a robot voice because of these facilities. Yeah, we are using the 4G already. Now, they are promising us to roll out the this December and also early next year, just for the mid band and also for the low band frequency. We have 5G tested sites in Langkawi Island. They have done a lot of testing, and it's actually working. And now doing the installment for the 5G backbones and also networks. Yeah, for me is the costing.
Yeah,
isn't it true, Mr. Lukman?
Yes, it's true. But do you think?
So we need to get investors.
Oh yeah, that's for sure. Yeah, because everything needs funding. Yeah. So, do you think this pandemic situation demands countries, to foster the advancement of the development of this technology quicker?
Yes. Yes, that is very true, because now we heavily rely on the internet coverage. We want to do the streaming of the video, right? So this we need to ensure that minimum latency, extreme high data rate, so that it can be a very smooth meeting, a very smooth video conferencing. Yeah, sometimes my network connection is also unstable, although I'm using very fast. In my country, we have optical networks, but still not very good in certain areas, for example, in rural areas. So this kind of facilities is very, very important in order to boost up our economy. And also now people are shifting, not shopping in the shopping mall anymore. We are now moving towards online shopping. So actually, when I studied in the US 20 years ago, we already start this kind of technology. I mean, the distance learning, the video, the remote learning, just by sitting at our hostel, our apartment, and the lecturers are recording, and we can video streaming this. 20 years ago in the US.
Amazing.
They are actually very advanced compared to us. And then we are doing the online shoppings using the debit card. But in Malaysia, I observe now we are starting that kind of trend. Okay, so I think this pandemic has pushed us forward to optimize all of these facilities. But actually, it makes our life easier. We don't have to go to the shopping mall anymore, travel, drive our car to that, and spending more hours. So just by clicking using your smartphones, and you can shop around for a lot of things. So it's actually benefits to us and also to our family in terms of health and so on. I think we are most awaited for this 5G. We are very eager because it of course it will boost up our economy dramatically. Yeah,
I agree.
We can compete with advanced countries like China, Japan, Korea. Yeah, we are amazed by their technologies, right? So now they are leading because they already have the 5G. They are pioneering in the 5G facilities and also equipments, of course. Like China, they have Huawei, right? In Europe, they have Ericsson. In the US, So hopefully that we, as a developing country, can cope up with their advanced technologies, so that we can be more prosperous. We can generate more income to our countries, and also we can distribute these prosperities, the monies to our rural communities, and also in many areas, especially for the educations and also for the research and innovations.
All right, thank you very much. Last question from me is, as technology professor, do you have any message to the students that attend our meeting today in terms of using technology, perhaps you have some advice or how to use technology properly, and when we should not use technology too much, something like that. Do you have any message to our students here?
Yeah. Yes. My message is you have to use the technology and also equip yourself with the knowledge. Yeah, technology is comes with the pro and cons. So now we are looking for at the pro perspective. I mean the positive perspective. You can gain a lot of knowledge even though we are not face to face. You can invite all over the top scientists and also renowned researchers from all over the world and share with our students just by sitting in front of the PCs, right? So it's very convenient for me. Also, I don't have to travel anywhere, but you have to use it carefully, not to be obsessed with the technology. I know that youngsters, teenagers, they like to upload their recording things, activities in the TikTok, in the Instagram, or perhaps they like to venture in some not a very good website. So you have to limit yourself. I mean, you have to know your boundary. Okay, it is okay for you to get entertained with this kind of technology, but do not go beyond the limits. You have to set time. Okay, so let's say you spend your daily life staring at the phone for 7 hours. It is not good for your eyes. Actually, it is not good. Even me also, I get infected by this kind of technology. So when I have to work for a very long time, it affects my eyes and also I get headache and so on. So in order to make it ergonomic, you have to limit your time. Just spending not, 2 hours per day or perhaps 15 hours and you need to take a rest, or you can put your mobile phone not a very high power of the light. Okay, so please use it wisely for the advancement of your future career and also your future study. Okay, so yes, technology can be entertaining, but you also bring the dark side of it. So you have to be very careful, and in order to be bound with these positive vibes of the technology, to get yourself knowledgeable and also educated, you need to not to expose yourself with this negativity caused by the technology.
All right. Thank you very much for your advice to our audience here.
Make
and
you
also
more
your
humane.
presentation. Yeah, it's been a great honor to have you here, Dr. Hasliza. Hopefully we can see each other in the real world later if the condition is getting better. Yeah, I would like to visit again your country.
Yes, sure.
Yeah, we.
Come here, Mr. Lukman, please.
Yeah.
Bapak Lukman, come
The
here.
last time I visited Malaysia was in 2019. That was before the pandemic. Yeah, so I would like to.
Oh, same with me. I went to Aceh.
Oh, really? Yeah.
I went to Aceh. Yeah, it's a very nice place. So I'm planning to visit Medan and also Riau because I have collaboration over there.
Yeah, you have to visit East Java. Yeah, we are here in Malang City near Surabaya, the capital city of East Java. It's only 1 hour driving from Surabaya.
Oh.
Later we will welcome you here if you come here.
Okay, please contact me.
All right.
Mr. Lukman.
All right. So
thank you.
Thank you very much. And as your suggestion, we have to hinder ourselves from being too much in front of the laptop. So I have to I have to end up this meeting. Yeah. So we can have rest for a while before we continue to our next work. Thank you very much again to Dr. Hasliza and to other speakers, yeah, Professor Abbasi and Dr. Lisa for presenting. And ladies and gentlemen, once again, your question to Dr. Lisa will be answered later. So we will get back to you with the response from her. Yeah. So from this session, I would like to end. And I'm sorry if I have some mistakes in my words, in my gesture, my attitude. And I will get the event back to our wonderful MC, Mbak Indri Ayu Wirati. Please, Fitri.
Yeah, this. Can anyone hear my voice?
Yes.
Yeah. Okay. I'm sorry for this little bit trouble over here. Thank you so much for Mr. Alia Lukman Aziz, our moderator today, for a lovely discussion, such an informative for me as a person. So ladies and gentlemen, this is all about first Lekantara annual conference on engineering and information technology. May give us knowledge, motivation, and inspire all of us. So I am Indri Ayu as your master of ceremony today. Apologize if there's any mistakes and shortcomings for this event. Finally, good afternoon and see you next time.
you.